Welcome to clickmyproject.com. The title of this paper is Optimizing Bloom Filter Settings in Peer-to-Peer Multi-Keyword Searching. This comes under the domain data mining. What is Bloom filter? Bloom filter is a data structure which is an effective way to reduce communication cost in the field of information retrieval. This paper mainly deals with the concept of information retrieval. What is information retrieval? Information retrieval is nothing but searching for something, a document or something, by using a query keyword is called as a information retrieval. While giving such keywords, multi-keyword searching is more common. In order to avoid problems that happens in multi-keyword searching in peer-to-peer network, Bloom filter settings were introduced. In order to optimize those Bloom filter settings, this paper have been proposed. Existing peer-to-peer retrieval mechanisms provide a scalable distributed hash table that allows every individual keyword to be mapped to a set of documents or nodes across the network that contain the keyword. Using this single keyword based index, a list of entries for each keyword in a query can be retrieved by using existing DHT lookups. For multi-keyword search, the simple solution which merges the results of each keyword search incurs a lot of traffic. For example, considering two keyword query, for example peer-to-peer network, the query is decomposed into peer-to-peer and network, and then the two keywords are searched separately with a consequence intersection operation. A potentially large amount of data traffic will be raised across the wide area network. To reduce this content, a Bloom filter settings have been introduced. A Bloom filter is a lossy but succinct and efficient data structure to represent a set S which can efficiently process the membership query such as is the element X in the set S. By transmitting the encoded sets instead of raw sets among peers, the communication costs can be effectively saved. By applying a Bloom filter is not difficult, but how to get optimal results in terms of minimum communication cost is not trivial. In this work, we show mathematically that the optimal setting of Bloom filter in terms of communication cost is determined by the global statistical information of the involved items on both sides, not the minimized false positive rate as claimed by the previous existing systems. We also demonstrate how to get optimal settings through numerical analysis. Two algorithms were proposed in this work. They are AND algorithm and another one is OR algorithm. AND algorithm performs AND operation in the given multiple keywords, and OR algorithm performs OR operations in the given multi-keyword searchings. The main contribution of this work is to mathematically show the optimal setting of Bloom filter and to derive an effective approach to achieve Bloom filter optimal settings through numerical analysis. Many existing systems have been proposed for this multi-keyword searching, but some of them existing system uses every individual keyword to be mapped to a set of documents across the network that contain the keyword. There are generally two types of decentralized peer-to-peer search engines: federated search engines over unstructured peer-to-peer networks, and DHT-based distributed global inverted index on top of structured peer-to-peer networks. In federated search engines, peers that maintain indexes of their local documents are organized in an ad hoc fashion. A simple search method is flooding. Each query is tagged with a maximum time to live to limit the number of hops in travels. In order to reduce the search cost, many approaches have focused on the issue of query routing, but the drawbacks in those existing systems are retrieval of keyword in a query is difficult and the traffic cost is high while searching. Bloom filter reduce the traffic cost but not effectively reduce the cost. Now we will see about the proposed system. In a proposed system, a hybrid peer-to-peer network is a combination of an unstructured peer-to-peer network and a BF-enabled overlay-based DHT global inverted indexes. With the facility of this, the system utilizes a push synopsis gossip algorithm for gathering the global statistics information such as keyword popularity. Our approach is general to any of these DST techniques. For simplicity, the following discussion assumes architecture closely related to the code protocol. In order to reduce the communication cost, we use a Bloom filter for distributed intersection and union required by the multi-keyword search. Now I will explain the concept regarding that AND operation, and the same thing is followed for OR operation. See the figures A and B. For in the figure A, this is the peer 1 and it sends a query on x and y. This performs operation only on x and returns the entire x to 2, and it performs the y keywords operation, and it sends the x result along with y's result to 1. This is the high cost method, and in order to reduce the cost performed in figure A, we use the Bloom filter settings in figure B. For example, this enables the query, and this searches for the Bloom filter of x keyword in the settings, and it returns only the BF of x query to the y keyword, and the y keyword searches the document along with the BF of x alone and returns the result to x, and the x keywords peer returns the result to the user. This is the operation of the AND algorithm, and same way the OR algorithm is also proceeded. Now I will explain the system architecture of this process. Initially, we have to construct a network based on the peers, and the peer count is according to the user space. Then we will collect the documents that contain some user query keywords. This process is done before issuing the user query. We will collect those document details, and we will provide some document IDs to each document. Then we will create the query list, and we will assign query to nodes, and that gets stored in the database. We will assign the documents to nodes, and that also gets stored in the database. We will combine both document node details and the node query details to construct a Bloom filter. This Bloom filter will contain which query is contained in which document, and which document is contained in whatever peers. Likewise, a Bloom filter structure will be created, and it will be get stored in a database. While user issues the query, the queries will be splitted into 1 and 2, and the corresponding respective node will be selected from the database, and it is retrieved from the Bloom filter settings, and the result is returned to the user query. This is the flow of the project. Now I am going to show the demo of this project. For this we need NetBeans. After loading the project into NetBeans, select home.java and click run file, and click here, select construct the nodes and draw edges between that, and collect the documents and the hash ID for that and the size of this, and allocate documents to the peers. For each peer we will allocate a document with the some set of documents to each peer, and we will collect the query list and the idea for that, and we will allocate again queries to the peers. After allocating, click next. The document list will be shown here, and the node list will be shown here, that is which document is contained in whatever peers. Then click next and show. This mentions which query is presented in which document and wherever the node occurs. Then hash table, in the sense Bloom filter settings. This is the Bloom filter settings, this is the query ID, and this is the document ID. This shows that query ID 14 is present in 5, 8 and 9, and document 5 is present in peer 3 and peer 4. Then search process, click the word to be searched, for example data, and select AND operation, and click mining, and click enter. Click search. The resultant documents will be displayed here. This is the result of our proposed work. Thanks for listening the video. Thank you.